Hello everyone, in this video we'll be solving problem 209 minimum size subarray sum. The problem statement is given an array of positive integers nums and a positive integer target, we need to identify a minimum length of subarray whose sum is greater than or equal to the target. If there are no such subarrays, return 0. In example number 1, the target given as 7, there are multiple subarrays whose sum will be greater than or equal to 7, but the smallest one is at the end with 4 and 3. Hence the output is 2. Similarly, in example number 2, the target is 4. The minimal length of the subarray is 1 as we can only have 4 in the subarray to meet the criteria. The problem statement is very easy and straightforward. Let's switch to whiteboard and discuss couple of approaches to solve it. Simplest way to solve this problem is to use brute force approach, where we'll try to build a subarray of all possible combinations, calculate its sum, and compare the sum against the target. If the total is greater than the target, then we'll record the length of the subarray and save it in a variable. Only the minimum length will be saved in this variable. We'll try all possible combinations of subarrays that will meet the criteria, and if yes, we'll compare its length with the length variable and save only the smaller value. Let's run a couple of simulations to understand this better. Starting with I is equal to 0 and j will point at I plus 1, that is index 1. Sum of this subarray is 5, which is less than the target. We'll increase the size of the subarray by incrementing j by 1. Now j is pointing at 1, so the updated total is now 6. As the total is still less than the target, we'll repeat the same process and increment j. This time j is pointing at 2. Including it in the total will result in 8, which is greater than the target. As we found the first subarray that matches the criteria, we'll save its corresponding length in the length variable. As we are looking for the minimal subarray, there is no point in incrementing the j value. We will instead focus on building a new subarray with a new starting point. So I will be 1 and j will be I plus 1, that is 2. We'll try to check for the subarray just like before with these starting points to see if the criteria is met. After going through all the combination, we'll increment I. We'll continue to do that until I is pointing at the last element in the input array. And we have tried all possible combinations of the subarrays. With this solution, our time complexity is O of n square, where n is the number of elements in the input array. Time complexity is n square because we are running nested iterations with two different pointers and trying all possible combinations of the subarray to check for its total against the target. As we are using couple of variables for the for loop to record the range or the size of the subarray and size of the minimum subarray that matches the criteria. One concern with this approach is the duplicate calculation that happens as we increment our pointers. For example, the step to calculate the total of the subarray between 2, which is index 0 and 3, is being repeated again when we incremented I to 1. Not the entire thing, but few elements of the subarray are overlapping between the two. The same pattern will continue as we increment our pointer. Now let's think of improving that aspect of the solution. As we are trying to work with a subarray where the elements should be contiguous in nature and the sum should be greater than or equal to the target, the most suitable algorithm in this case is the sliding window with two pointers. In this approach, we use two pointers left and right, which points the start and the end index of a subarray, and based on the criteria we decide, either of the two pointers will be incremented so that we can adjust the range of the subarray. Let's run through a simulation to understand how this algorithm will help us solve the problem. We'll start with left pointing at index 0 and right pointing at index 1. The total of this subarray is 5. As the total is less than the target, we need to extend the range. So we'll increment the right pointer and bring in one more value into the subarray. The new total is 6, which is still less than the target. So we'll again increment the right pointer to bring in one more value. With 2 in the subarray, the total is 8, which is greater than the target. As this is the first valid subarray, we'll save its length in a variable. Now we need to figure out if we can trim this subarray and still meet the criteria. We can do this by incrementing the left pointer and removing the first element from the subarray. My left pointer is pointing at index 1. As 2 is no longer part of the subarray, we should remove it from the total as well. So the updated total is now 6. After this change, the total is no longer greater than the target. Similar to the previous operation, we now need to increment r to bring in one more value into the range. Including 4 into the subarray, the total will be 10, which is greater than the target. So we found one more subarray with length 4 that matches the criteria. Now we'll try to shorten the subarray by incrementing the left pointer to see if the condition is still sufficed. As part of shortening, we'll remove 3 from the subarray total as it is no longer part of it. So the updated total is 7, which is still equal to target. So the criteria is met and the size of the subarray is smaller than the previous array that we have calculated. So we'll replace the value. So now the minimum length of the subarray whose total is equal to or greater than target is 3. As the criteria is meeting, we'll try to optimize our array even further. Now we have two elements in the subarray, 2 and 4, whose total is 6, which is not greater than or equal to the target. The criteria is not met, which means we need to increment the right pointer. With 3 elements in the subarray and the total is 9, it matches the criteria, but as its length is not smaller than the minimum length that we have calculated, minimum length will not be updated. Now we'll try to string the window by incrementing the left pointer. Now it is pointing at 4 and 3. There are 2 elements and the total is 7 as we remove 2 from the original total. As the length is smaller than the minimum length, we'll replace 3 with 2. As we have iterated through all of the combinations in the given input array, we'll jump out of the loop and return length as our output. To summarize, we used the sliding window to determine the size of the subarray by using 2 pointers, and depending on the total of the subarray, we incremented the pointers appropriately. And every time the condition of total greater than or equal to target is met, we were saving the length of the subarray inside this length variable. With this solution, our time complexity is O of n. Even though we have 2 pointers iterating through the array in its own way, the overall time complexity is O of n. And the space complexity is O of 1 as we are only using couple of variables, one to record the total of the entire subarray, the other is the length of the minimum subarray that meets the criteria, that is total greater than or equal to target. I hope you were able to understand how we improved our time complexity significantly by using the sliding window approach. Now let's walk through the solution in Java. Here's the solution in Java. I start by initializing 3 variables, the minimum length of the subarray and setting the default value to the max value, the window sum, which will be the total of all of the elements in the subarray, and the left index or the window start. After that, I'm starting a for loop which will be used to determine the right index or the window end index. In the for loop, we take the value that the window end pointer is pointing and add it to the window sum. If the window sum is greater than or equal to target, it means the criteria is sufficed. Now we need to figure out the smallest subarray that can still fit the criteria. Before we shrink the size of the subarray, we need to first save it in the minimum length variable by comparing it with the previous value and make sure the smaller value stays. We'll use the difference between the right pointer and the left pointer to calculate the window size. As we are shrinking the subarray from the left, we'll remove the first element that the left pointer is pointing from the total sum and increment the window start pointer, that is the left pointer. Once the for loop is complete and the minimum length is still equal to the max value, it means we did not find a valid subarray, so we return 0 as our output or else return minimum length as the output. This code when submitted on LeetCode beats nearly 100% of the submissions in terms of runtime and 42% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.